Let's work on this last problem of this question, last part of this question. We have another partial fractions technique problem. I'm going to write the partial fractions here. And observe that the first factor is a linear factor, which is non-repeating because the power is 1. And the second factor is a quadratic irreducible factor, but it's also non-repeating because power is 1. So for the linear factor, we will have one fraction with the constant numerator plus. For the quadratic irreducible factor, we only have one fraction because it's non-repeating. But in the numerator, we have to write a linear function. Okay, so something like bx plus c. Our goal here is to be able to find all these constants a, b, and c. I make the common denominator. A will have to be multiplied with x squared plus 9 plus bx plus c. The whole thing have to be multiplied with x minus 1. The left hand side, the numerator is just 10. So 10 would be equal to a times x squared plus 9 plus bx plus c times x minus 1. We can do this because both of them have the same common denominator. Now we are saying that these two fractions should be same for all x. So I can put any x value here. Let's say x is equal to 1. If x is equal to 1, the left hand side is still 10. Right hand side is 1 square plus 9 plus b times 1 plus c. But this factor 1 minus 1 is going to make this whole thing 0 because 1 minus 0, 0 times anything is 0. So what we are left with is 10 equal to a plus 1 plus 9 is 10. A should be equal to 1. We found our first constant. Now, this is true for all x values. I can't have another x. This x1 came from one of the factors, but I don't have any other x values right now. So I'm going to just say, let's say x is 0 because 0 is easier to handle. On the left hand side, x is 10. Right hand side is 0 plus 9 plus b times 0 plus c times 0 minus 1. So what do we have? 10 is equal to, I can put a1 now because it is 1 times 9 plus b times 0 is 0. So c times negative 1. So basically we have 10 equal to 9 minus c. C would be equal to 9 minus 10, negative 1. So c is negative 1. So we also found C. A and C are done. We are only left with B. Let's work on to finding B. I already use x equal to 1 and x equal to 0. I can use any x I said. So I'm going to try, say, maybe negative 1. We are putting all these values in the same equation. Remember that, okay? 10 equal to A times x is negative 1 now. Negative 1 square plus 9 plus b times negative 1 plus c times negative 1 minus 1. Let's write all this down. 10, negative 1 square is 1 plus 9, 10. So 10, a is also 1 plus negative b, c is negative 1 times negative 2. This 10 on each side will just cancel. So we have negative 2 multiplies inside. We will have 2b plus 2 equal to 0. 2b is equal to negative 2. B is equal to negative 2 by 2, which is negative 1. So we found that b is equal to negative 1. So using these three values, a, b, and c, and our partial decomposition, we can write our integral as a by a is 1, so 1 by x minus 1 plus b is negative 1, c is negative 1 by x squared plus 9 dx. So we have this as now two integrals, 1 by x minus 1 minus negative can come out, x plus 1 by x squared plus 9 dx. The first one is done. I know the integral of that is natural log of x minus 1 minus. The second one, I can split it further. I can write it x by x squared plus 9 dx minus 1 by x squared plus 9 dx. Okay. Now, to handle this second integral, I will have to, for this second integral, I'll have to do some u substitution. U is equal to x squared plus 9. Du would be the derivative 2x dx. We have x dx, that is actually what gave me the clue. So x dx would be equal to du by 2. So let's write this down. Natural log, this one is done, so don't forget to write that, minus integral x dx. That can be replaced by du by 2 goes out, and x squared plus 9 can be replaced by 1 by u. X squared plus 9 is u. Okay. Minus this last integral here can be done using the formula 1 by x squared plus a squared dx. The formula is 1 by a tangent inverse x by a. So in this case, a squared is 9, so a is 3. 1 by 3 tangent inverse of x by 3 plus c. We only have left the second integral to work out. Natural log of x minus 1 minus half. 1 by u's integral would be natural log of u minus 1/3 tangent inverse of x by 3 plus c. Natural log of x minus 1 minus half. Natural log of u can be replaced back into x squared plus 9 minus 1/3 tangent inverse x by 3. This is your final answer to the original integral. So let's go quickly the framework. You need to first use the fraction to decompose it using the partial fraction decomposition techniques. When we find all ABC methods using the partial fraction techniques, we put them back. We split the integrals the way we can solve them and then write the final answers.